Welcome to Brain Vision.
Alright guys, let's take a look at the question. The question was asking us how much helium is lost per hour. Well, in order to determine how much helium lost per hour, we need to figure out how much heat was burned, okay? And how much heat was burned is related to the heat currents equation here, which is the net heat radiation equation. It's H equal to A times E times sigma times T1 to the power 4 minus T2 to the power 4. A is the surface area of the cylindrical metal can. E is the emissivity. Sigma is the Stefan constant. T1 is the temperature of liquid helium, and T2 is the temperature of liquid hydrogen. Okay. It seems that we got the value of E, the value of sigma, and the value of T1 and T2, but we don't have the value of surface area. So in order to determine the value of the net heat radiation, we need to find out the value of the surface area. Well, there's the equation for the surface for the cylindrical surface area, which is A equal to 2 pi r times r plus h. We know the height h is 0.25 meter. What's the r here? What's the radius here? Well, from the question, the diameter was given, so the radius was just simply equal to the diameter divided by 2, which is 0.09 meter divided by 2, and this will give us 0.045 meter. So the surface area of the cylindrical metal is equal to 2 pi times 0.045 meter times 0.045 meter plus 0.25 meter, and this will give us the surface area of the cylindrical metal is 0.083 meter squared. So now we have the surface area. Now we can determine the value for the net heat radiation, which is equal to such things: H equal to E times sigma times A times T1 to the power 4 minus T2 to the power 4. If we plug in value, we should get negative 0.03360 watt. It's because you see at the end it was 4.22 Kelvin to the power 4 minus 77.3 Kelvin to the power 4. So if a small value minus a large value, it will give us a negative value. But it doesn't matter because eventually it will cancel out, and I will show you why. Okay. And now we have the heat current, okay, which is like the power. So in order to determine the heat, we need to multiply by the time. And remember, watts can be equivalent as joule per second. And we're talking about how much helium was lost per hour. So in 1 hour, there's 3,600 seconds. Okay, and we know that we only need to determine the amount of heat that was burned. So we can just make the value positive because the negative at this point is meaningless. Okay, so this will give us negative 0.03365 watts times 3,600 seconds, and this will be positive 0.03365 watts times 3,600 seconds, and this will give us 120.978 joule for the heat that is burned off during the process. Okay, and remember from the question, the latent heat of the helium was given, which is 2.09. Okay, so latent heat for the vibration of the helium was 2.09 times 10 to the power 4 joule per kilograms. Okay, so now we have the heat, and now we have latent heat, so we can determine the mass of helium that is burned off, which is M equal to Q divided by L. And this will give us 120.978 joule divided by the latent heat, which is 2.09 times 10 to the power 4 joule per kilogram. Okay, and this will give us, let me double check, 0.00 579 kilograms. If we convert it to grams, this will equal to 5.79 grams. Okay? And that's the answer for this question. So about 5.79 grams of helium we lost per hour. Okay? Thank you.